Okay, let's see how we can balance equation with polyatomic ions. And we'll write the equation for the reaction of solid aluminum with aqueous sulfuric acid to form aqueous aluminum sulfate and hydrogen gas. Okay, so we have first and foremost solid aluminum, and we have sulfuric acid. And the fact that it's got an ic, it means it came from sulfate. It came from the 8 ending. And sulfate is got this chemical formula, and it's an acid, so it's going to begin with a hydrogen. But we know that hydrogens have a positive 1 charge, so we have to do a crisscross charge here, and so we end up with H2SO4, and this is aqueous, and this forms aqueous aluminum sulfate. So let's see, aluminum has got positive 3, sulfate has got negative 2. So we're going to crisscross charges, and we'll end up with aluminum 2, and then parentheses around the sulfate because now we have more than 1, and we have 3 of those. And this is also aqueous plus hydrogen gas. And hydrogen gas is written always as diatomic because remember we talked about the diatomic elements, and they exist in nature as 2 atoms combined together. Alright, so now we wrote the skeleton. Let us begin to balance the equation. We'll look at the element that occurs in only one compound on both sides, and so that's aluminum and sulfate. But since aluminum is freestanding here, let's go ahead and balance the sulfate. And notice I'm saying we're going to balance the sulfate because we treat the sulfate ion as one unit. We don't look at it as 1 sulfur and 4 hydrogens. We look at it as 1 sulfate unit. So we have 1 sulfate on the left and 3 sulfates on the right. So to compensate for that, we're going to put a 3 right here. Okay, now let's do aluminum. Aluminum, we have 2 here on the right and 1 on the left. So let's put a 2 here as a coefficient. And finally, let's look at hydrogen, the freestanding element. So we have 6 hydrogens here. That means we'll put a 3 right here to make that a 6. All right, we don't have fractions, and let's look to see if we got everything balanced. We have 2 aluminums on the left, and we have 2 aluminums on the right. We have 6 hydrogens on the left, and we have 6 hydrogens on the right. We have 3 sulfates on the left and 3 sulfates on the right. So it looks like we're all balanced. Alright, go ahead and give this a try. Write a balanced chemical equation for the reaction of aqueous lead-2 acetate with aqueous potassium iodide to form solid lead-2 iodide and aqueous potassium acetate. Okay, lead 2 and acetate has the formula C2H3O2, and it's got a negative charge. That's why I made you memorize all those, remember? So you can, because we build on it. We're going to use them over and over again. So now let's crisscross the charges. And so we end up with lead 1, because the negative 1, we don't have to write that. And we put parentheses around the acetate because we have 2 of those. And this is aqueous plus we have potassium iodide because this is reacting with potassium iodide. Okay, so potassium has got a positive 1 charge and iodide has a negative 1 charge, so that should be really easy. And this is also aqueous. Alright, and this is forming solid lead-2 iodide. Okay, so we have lead, 2, and iodide. It's got -1. We crisscross charges, and we end up with lead, 2, iodide. And this is also aqueous to give us potassium acetate. And the potassium's got +1, and the acetate has got -1. So we write it like so. Okay? And this is also aqueous. Alright, now that we wrote the skeleton, let's go ahead and balance the equation. We have lead that occurs in one compound on both sides, but it's already balanced. We have the acetate ion. See, again, because it's a polyatomic ion, we're treating it as one ion, not as 3 individual elements of carbon, hydrogen, and oxygen. That would be really hard to balance. So we have 2 acetates on the left, and we only have 1 on the right, so let's put a 2 here. Okay? Now, when we've done that, we've said, okay, there's 2 potassiums on the right now, so, and we only have 1 on the left, so I'm going to go ahead and put a 2 right there. Now, we have 2 iodines on the left, and we have 2 on the right, so we're good with that. We don't have any fractions, so let's just make sure that we have the correct number on both sides. We have 1 lead on the left and 1 lead on the right. We have 2 acetates on the left, and we have 2 acetates on the right. We have 2 potassiums on the left and 2 on the right, and we have 2 iodines on the left and 2 on the right. So we are all balanced.